Hello viewers, welcome back to my channel. And in the previous video we talked about how we do the principle of mathematical induction problem. So in this video we are going to talk about another question in the mathematical induction problem, and it says you should prove that 1 squared plus 2 squared plus 3 squared plus plus n squared is equal to n multiplied by n plus 1, the whole expression multiplying 2n plus 1 all on 6. So we have to prove this series. The sum of this series is always equal to this for any value of n where n is a natural number. To do that, you have to use the principle of mathematical induction. So let's see. So first of all, to go by this, you have to test for your base case. So for the base case, you have to prove that the statement is true for n is equal to 1. So for n is equal to 1, on my left side I'll put 1. That will give me 1. That is, if you say n is equal to 1, the sum of the first term, that will be 1 squared. So I'll have 1 squared to be equal to this side. Wherever I see n, I'll put 1 there. So I'll have 1 multiplying 1 plus 1, 2 multiplying 1 plus 1 all over 6, and this will give me 1. That is the left side to be equal to, if I have 1 plus 1, that will give me 2. 2 by 1 will be 2 plus 1 3. So the 2 by 3 will give me 6. So I'll have 6 on 6, and I'll get 1 is equal to 1. Therefore my base case is true since the left hand side and the right hand side are equal. So from here we move to our induction hypothesis. So for the induction hypothesis, we have to assume that the statement is always true for n is equal to k. So assuming that the statement, assuming n is equal to k, is true, that is our assumption, and that is the induction hypothesis. What do we get? We get 1 squared plus 2 squared plus 3 squared plus plus, wherever you see n, we put k, since we are assuming that n equals k is always true, plus k squared to be equal to k multiplying k plus 1, then 2k plus 1 all over 6. So when you assume that n is equal to k, we are going to have this. So this is our assumption, and from this that we can go on with our proof. So let's quickly go to the inductive step. That is the main proving. So in this step, we have to prove that the statement should be true for n is equal to k plus 1. So how do we do that? From here, wherever you see n, you put k plus 1. But in the series, the k plus 1 term, you add it to it, but it will be all squared. So we have 1 squared plus 2 squared plus 3 squared plus plus k squared, then the plus k plus 1 all squared. So this is the k plus 1 term. Here is the k term, so the k plus 1 term will follow. That is why we have this here. This should be equal to k plus 1 multiplying k plus 1 plus 1, and also multiplying 2 open bracket k plus 1, because wherever we see n, we are putting k. So 2 multiply k plus 1, then plus 1 all over 6. So our aim is to show that the left hand side and the right hand side are equal. Therefore our inductive approach will be valid and our statement will be true. So to do that, we know that from here 1 squared plus 2 squared plus 3 squared up to this side is the same thing we have in our assumption, and it's equal to this. So we just make direct substitution here. So this whole part will be replaced by k open bracket k plus 1, then 2k plus 1 all over 6 plus k plus 1 all squared, that is this one, should be equal to k plus 1 multiplying here will be k plus 2, and also multiplying, we're having 2k plus 2, so here will be 2k plus 2, so we get plus 1, so to be 2k plus 3 all over 6, like this. So we move forward. Now if you're having an algebraic expression, we assume that this is over 1, so they will cross multiply and multiply the base or the denominator. So you have k multiplied by k plus 1, multiplying 2k plus 1, then plus 6 open bracket k plus 1 all squared all over 6 to be equal to k plus 1 multiplying k plus 2, then multiplying 2k plus 3 all on 6. So from here, let's bring k plus 1 out here, so that when we factorize k plus 1 out here will be left with k, then 2k plus 1, then also here will be left with plus 6 open bracket k plus 1, like that. So once you have this, you close the brackets all over 6 to be equal to k plus 1. Now let's multiply what we have here inside. So here we have 2k squared plus 3k plus 2k, plus 4k, then plus 6 all over 6. So at this point, we move straight to our simplification, k plus 1 out. Then here we have 2k squared plus k, then here will be plus 6k plus 6 all over 6 to be equal to k plus 1. Here will be 2k squared plus 7k plus 6 all on 6. So at this point, we will still go on simplifying so that you show that the left hand side and the right hand side will be equal. So we have k plus 1 here multiplying 2k squared plus 7k plus 6 all over 6 to be equal to k plus 1 multiplying 2k squared plus 7k plus 6 all on 6. Since our left hand side is now equal to our right hand side, we state that the statement is always true from our principle of mathematical induction. So the statement has now been proven, and you can see that this statement that 1 squared plus 2 squared is always equal to this for all natural numbers. So from our proof, we arrived that the left hand side and the right hand side are equal. So our statement has been proven. Thanks for watching. Kindly subscribe and like. Follow me as I'll post similar videos in this topic. Thank you.